Before switching on the system to run your magnetic nanoparticle samples, make sure everything is connected properly once again. Especially make sure that the water inlet and outlet is OK, as the coil enclosure will not switch on if they are not connected properly, or if the water inlet pressure is below or too far above 320 milliliters per minute. After that, look into the reference matrix sheet for your Magnatherm system, which shows you the exact combination of coil, capacitor box, DC power supply setting, and function generator setting to achieve the magnetic field strength required. This sheet is unique for every system and is provided by Nanotherix for each system. If you want to test your sample at 110 kHz with 25 millitesla, switch on the function generator first and input 110 kHz. Make sure the current is set to its maximum and voltage is set to its minimum in the DC power supply. Now switch on the DC power supply, coil enclosure and the oscilloscope. Take 1/3 of the voltage input for 110 kHz from the matrix sheet, 10 volts. Now slowly increase the voltage to 10 volts and you will observe a peak-to-peak voltage increase in the oscilloscope signal. Now tune the circuit to its resonant frequency, the frequency at which the amplitude is high within the LC circuit. When this tuning is done, lower the voltage back to 0. Now take the sample, make sure it is in contact with the optical probe, in this case connected to a single channel optical probe interface which monitors real-time temperature variation within the sample. Place the test sample within the polystyrene tube to avoid non-specific heating, which is already enabled by running cooling water within the coil and also by separating the coil from the sample by the polycarbonate wall. Increase the voltage slowly to its maximum to achieve the peak-to-peak voltage provided in the matrix sheet. Now you will be able to observe and record the real-time temperature change within the test sample. The power loss calculation program will provide the specific absorption rate, specific loss power, intrinsic loss power values for the test sample and facilitate the user access to the raw data in Excel format for further interpretation. The calibration liquid, i.e. 20 milligrams per milliliter of 50 nanometer size Magamite, which is provided with the system, will show increase in temperature over time, allowing the user to view magnetic nanoparticle heating in an AC magnetic field. Example sample data. Heating property comparison between 1 milliliter of different concentrations of Magamite, 50 nanometer at AC magnetic fields. Heating property. 1 milliliter of 100 milligrams per milliliter Magamite, 50 nanometer, at different AC magnetic fields. Heating property. Heating property comparison between 2 milliliters of DMSA stabilized magnetite, 50 nanometer, at AC magnetic fields.